In this video, we're going to be covering question 2 and question 3 of our unit review for unit number 2 for linear equations. So we're going to start off with question 2 here. Armin is going to be trying to figure out if he should buy a season pass or if he should just pay for the games he's going to go to. So here we go. We got Armin is trying to decide whether to buy a season pass or should he buy individual games. So let's go ahead and read this. Armin is trying to decide whether to buy a season pass to his college basketball team's 20 home games. So remember, they have 20 games this season. The cost of an individual ticket is $14. Okay, so each game is $14. This is cost per game. All right. And the cost of a season pass is going to be $170. Okay, so my season pass is going to be the $175. Oh, and remember, we are looking at 20 games that he could go in total. So 20 games is our total here. 20 games. The season pass will admit Armin to any home basketball game at no additional cost. So the season pass, he can just go for free as long as he has that season pass. He pays the $175. He goes for free every game. What is the minimum number of basketball games Armin must attend this season in order for the cost of a season pass to be less than the total cost of buying an individual ticket for each game he attends? Well, let's just figure this out. So I'm going to break this into two different options. I could go over here on the left. I'm going to look at season pass. Okay. And on the right here, I'm going to individual games. I'm just going to pay per game. All right. So let's pretend in our season pass land, all right, let's split this down the middle. Let's pretend that I only have time to go to one game. One game. Okay? How much money do I end up paying? Well, my season pass is a fixed $175. So one game costs me $175. That's insane. Over here at pay per game, if I go to one game, well, it's only $14 a game. So that's not going to be bad at all. I get to go for just $14. Now, let's pretend I go to every single game this season. That is 20 games. 20 games. What's my total over here? It's the same boring total. It's a season pass. It works for the whole season. So I'm paying $175. Or over here, 20 games is going to be 14 times 20. So it's going to be 14 times 20, which equals, let's see, 14 times 20. Oh my God, $280. Miss me with that. Here we got $280. Yikes. So clearly there are some scenarios where the season pass is going to be better and some scenarios where the pay per game model is going to be better. But where is that flip point? Where is that flip point? I think what we're going to want to do is basically see how many games I can go for this 170. So basically, I would want my cost. Here's my equation for my pay per game. Let's just put it over here with the pay per game. Right here, over here, my cost equals 175, period. Over here, my cost equals 14x, where x is the number of games. So the number of games. Okay? So basically, we are going to want to set these two equations equal. We are going to want to see when they are equal. So that would be the same thing as basically just saying over here, I'm going to say I have 175 and it needs to equal my 14x. And then you solve for x real easy. You just divide both sides by 14. By 14. This crosses out. And I'm going to get x equals whatever 175 divided by 14 is. And that's 12.5. So I have 12.5. So if he goes to more than 12 games, he should buy the season pass. We can actually graph this. As long as we convert these to XYs. So up here I had my cost equals 175. If I wanted to graph this, I could just set this equal to y equals 175. And over here it would be y equals 14x. And then you can play the same game. You can just go ahead and say y equals 175 and y equals 14x. And wherever these two things cross, boom, that's where it crosses right there. That's going to be the value. And look at it. It's 12.5, which makes sense. Makes a lot of sense. Another way we could prove this is we can put in the maximum number of games, which is 20 games. So at 20 games, right here where it crosses, either I could pay $175 or I could pay $280. That's a big yikes for me. I'm going to choose to pay the $175. Okay? So we can do this either way, graphing or just solving. All right, let's go to one where we can just look at the graph straight up. Question 3. Question 3 is about fishing. So, Fishing Adventures rents small fishing boats to tourists for a day-long fishing trips. Each boat can hold at most 8 people, okay? There's a lot going on in this story. So you can have 8 people in a boat. Additionally, each boat can only carry 1,200 pounds. So I have 8 people, 1,200 pounds of people and gear for safety reasons. Assume on average that an adult weighs 150 pounds. Mr. Sinclair doesn't weigh 150 pounds, I wish. 150 pounds, and a child weighs 75 pounds. Also assume each group will require 200 pounds of gear plus 10 pounds of gear per person. Yikes. So, basically, I think what they got going on here is they have 2 different equations, probably one for adults and one for children. It says which groups, if any, can safely rent a boat. So what we're going to want to do is we are going to want to look for groups that are in this zone here that is highlighted by both of our graphs. So group 1 has 4 adults and 2 children. So is 4 and 2 in here? So let's just look at this real fast. Is 4 and 2, it's either here or it's 4 and 2 is here. That one's in there. How about 3 and 5? 3 and 5, ooh, it's on the line. Or it's on the line here, 3 and 5. Ooh, that one's out. 3, group 3 has 8 adults. Huh. I think we're actually gonna have to model this one out.